Welcome to the Python track of episode 3. You know, episode 3 has been pretty theoretical. We've been talking about these notions like linear independence and the span and the basis and those sorts of things. It's not particularly computational, but we are going to do a couple things with the programming language this time. In particular, I want to talk about functions and loops and also about how to do some plotting. So here's the cheat sheet for this time. You will notice that there's 3 different sections here. The function section is what we're going to look at first. And then there's going to be something called a for loop, and then we're going to look at some plotting commands. So let me tell you about functions for a second. So a function is essentially a block of code that you want to be able to run more than once. And one of the things that every programming language supports, and one thing every programmer wants to do in just about every program, is to have some sort of way of modularizing the different pieces of functionality in the code so that you don't have to write it all in one big long sequence of all the operations. And one way of doing that is with functions, where you're able to say, hey, here's a little subroutine, a little part of code that makes sense as sort of being its own coherent chunk. And what we're going to allow that to do is be called in several different circumstances. Okay, so here's how you do it in Python. The syntax for this, you're going to say def, and then you're going to give it the name of a function, and that name should be something meaningful that describes what the function does. Then you're going to give it the inputs to the function, and remember that, you know, it goes by this funny name of argument, and so we're going to basically separate the arguments to the function by commas, and all the arguments are going to go inside a pair of bananas here, and then put a colon on the line outside. So there are functions that have no arguments, there are functions that have 1, 2, 5, 100, you can have as many arguments as makes sense for your function. Those are basically the particular inputs that function is going to take. Now, once the function is called, which means it's invoked, which means you actually trigger it, and keep in mind, writing it is not triggering it. First you write it, and then you will call it somewhere else, as we'll see. All of the statements in the function will get executed. And as I mentioned before, Python is very, very anal about indentation here. So all of basically the statements that are inside your function, you need to make sure are tabbed over, usually with a tab or with 4 spaces. If you put some of these statements that you mean to be in the function outside flush left, Python will not consider those part of the function. And that turns out to have a completely different effect on your program. Okay, so don't make that mistake. There's one special statement that you will typically put inside a function, and that is called the return statement. And the return statement is where you say, hey Python, if while you're executing the statements you come across a return statement, that means it is done, the function is complete, and I want you to give this value as the output to the function so that whoever calls it gets that output back. So this is related to the mathematical concept of a function, as you may have learned if you took all the math volume 1, where a function has a domain and a codomain, right? It has an input that you give it, and it always produces one output. Same sort of thing here. The thing that's hard about functions is that every programming language has this sort of clunky way of connecting the function itself to the code that's calling it. And it makes it a little difficult for newcomers to come by, especially because the names of the arguments are not necessarily the same inside the function as they are outside where it's being called. Also, the way that the return value gets stored in the piece of code that called the function is a little tricky. So let's see one in action. We talked before about linear combinations, and let's actually start our program here with our from numpy import splat, as we always do. I'm going to make a function here that can compute a linear combination of dominoes, and I'm going to call it linear combo. And I'm going to have it take 2 arguments. One I'll call N1 and one N2. And that's basically how many of domino 1 you want and how many of domino 2. And then I'll have the colon after that. And inside, here's what I'm going to do. I'm inside the function now because I'm tabbed over. So I'm sort of in a little insulated private area that only this function knows about. And I'm going to declare a variable called domino1. And I'm going to set that equal to the domino 1, 2. Remember our syntax before for declaring vectors. And I'm going to make it domino 2. And that's going to be 4, 4. So these are the same 2 dominoes we've been using all along. Now, how do I give the answer to this thing? Because really there isn't anything more I need to do at this point besides just give the answer. And you will remember that to take a linear combination, you take the number of elements or the number of copies of the first domino you want times that domino, plus the number of the second domino you want times the second domino. So it's really as simple as that. And if we save this and come down here and run it, so again, just writing the function here does not actually call it or make it happen. We've simply outlined what should happen if it's called. To call it, we would say, hey, I'd like a linear combo, please. And can I have 3 of the first vector and 2 of the second, please? And it says, sure. And the final answer you get is 11, 14. Or I could say, hey, I'd like 4 of the first vector and none of the second, please. And it gives me back 4, 8. You should verify for yourself that those are, in fact, the correct answers for these 2 dominoes. Now, as I mentioned, the names of the arguments here do not have to be the same as the names of the argument in your main program. In fact, here we didn't even have names. We just literally gave it the values 4 and 0. We could also have said, let's make an n1 that's equal to 4, and make an n2 that's equal to 0, and call linear combo and pass it n1, n2. That would give us the same answer. Heck, we could even make something called Sally and give it the value 4, and Dave and give it the value 0, and say linear combo Sally Dave. And that gives us the same answer as well, right? So no matter what I give no matter what's written here, all that really matters is what's the value of the thing before the comma and what's the value of the thing after the comma. Because the function is going to say, you know what, whatever you give me as those 2 arguments, I'm just going to call them n1 and n2 internally. I don't care what you call them. I don't even care if you call them anything. Those are going to be my private names for these things. All right. Just to get the return value part correct, because this is also a trouble spot for some students. So when I call linear combo and I gave it 4 and 0 here, what I could do is I could say Bob equals that. And what I'm doing there is I'm saying when this return happens, whatever the answer is computed as here, it's going to get returned and set equal to Bob. So now if I say, hey, what's Bob? It tells me it's an array. It's a vector with 4, 8 as the coordinate pair. All right? So that is a function. This is a nice little handy function that can compute a linear combination for us, right? We don't have to worry about doing all the math and combining stuff. All we have to do is call our function, and it does it with whatever pair of dominoes it knows about. Now, next thing I want to talk about is plotting. So here's your cheat sheet in the Python plotting portion. First thing we're going to do is import the Pylab library. There are other plotting libraries, but this is the one we're going to use. And then the most basic function we're going to use is pylab.plot, where you give it an x value and a y value, and then you tell it what character to put there, and it will make a little plot where it shows you that point. All right, so let's do that here. Let's say we're going to import Pylab at the top, and then we're going to say pylab.plot. Let's plot the point 3, 2, and make it a circle like that. And when we plot it, you'll see that it gives us a little plot here with this circle. Now you might wonder why it's in the middle of the screen instead of off center, and that's because if you look at the axes here, it has scaled the axes to sort of zoom in on this point. Normally what we're going to do is this. We're going to say, let's set the x limits to -5 and 5, and let's set the y limits to -5 and 5. That basically gives you the maximum and minimum value of the x-axis and y-axis, so you can sort of set them to something sensible. And then we're going to say show the plot like that. So if I run this thing now, you'll notice that it puts the point up here. Okay, so and we can plot as many points as we like. We could plot a couple more here. We could plot one at 0, 0. We could plot one at -4, 1, and if we run that, then we're going to get 3 points in the middle of that, right? Now, here's what I want to do. I want to generate a bunch of random linear combinations of those vectors and then plot them. And we're going to do that with the yellow dominoes and blue dominoes and sort of see the difference. Now, the way that programmers do this, if you have to do something a number of times, you don't just write the code itself a bunch of times in a row. Instead, what you use is something called a loop. And the one we're going to learn here in Python is called a for loop. And what we're going to do, and this is just sort of something to memorize for now, is to say for I in range banana, and then you give it a number, which is how many times you want the loop to execute. And then don't forget your little colon afterwards. And then we're going to have all the statements that we want to run, the parts that are part of the loop, indented here. Again, I just can't stress enough that that Python will only consider the statements to be inside the loop if they're indented over. Otherwise, it will think you're done with the loop and you're continuing to describe the main program. All right. So here's what we're going to do. I'm going to come up here and I'm going to say for I in range of 10. So we'll do this. We'll make 10 random points. I'm going to get a random number, and remember the way we do that is we say random.rand. And if we say random.rand of 1, that's going to give us a number between 0 and 1. I'm going to multiply that by 4 and subtract 2, okay, just so we get a little bit of variation here. So this is going to actually give us a number between -2 and 2 once I do that. And I'm going to set a variable. I'll call it n1, or maybe I'll call it random n1 here, and I'll set it equal to that. And then I'm going to say random n2. It's another random number. And then I'm going to make a variable called random LC for a random linear combination, and that's simply going to be the result of calling our linear combo function. So I'm going to give it random n1 and random n2 as its two arguments. Now, once I've done that, I want to plot it. So I'm going to say pylab.plot, and we want to go random LC of 0. That gives us the x-coordinate of the vector that we got as a linear combination. And then random LC1 is the other coordinate, and we'll say we want to plot a cute little circle here. And then notice these other lines here I'm going to put outside the function, meaning not indented, and that's crucial because I don't want to set the x limits and y limits and show the plot all these times. I just want to do that at the end. Therefore, by having lines 19 through 22 be indented, that's my way of telling Python that those are the lines that comprise the loop. Everything else I want you to do just once after the fact. So we run this thing here, and you'll notice it generated a bunch of points. And they are kind of sort of on this line here, right? They're sort of diagonal, and that's because, again, both of our dominoes are in a roughly northeast direction. You can't see 10 points here because our axes weren't big enough. Let's jack this up. How about -15 to 15? And then we'll be sure to see them all. And every time I run it, I get different ones, right? They're all sort of on that line. If I get 100 points instead, then I'll get more, and you can see that there's just a lot of them that are all kind of on that line. Now, again, I told you a couple segments ago that I was surprised at first that you could even get a point over here. It is possible, as we showed, but it's also true that it's not as probable as getting a number on a line because both of these things point in that direction. Okay? If I were to go up here and say, hey, instead of 1, 2, let's make it -1, 2. Then you can say it's much more spread out, right? Because now I've made these things point in totally different directions. Or if I said, how about -11, 2 are my two dominoes? Now I get them all over the place and kind of scattered in a different direction here, right? So it matters very much what the dominoes are. And let's just finish off by showing our blue case. So I think our blue dominoes were 2, 3, and 4, 6. And if I run that thing, then even with 100 points, they all line up exactly on this line, right? Because as we saw, if you have blue dominoes, you can't even cover the whole plane. You're always going to be only on the line or the smaller space that is spanned by those two dominoes. Thanks for meeting up with me on episode 3. Hope you learned a lot. I will catch you next time on All the Math.